The displacement x with respect to time, t, of a particle moving in simple harmonic motion is given by this equation, where x is measured in centimeters and t is measured in seconds. So using that equation, we wanted to determine the numerical value of several things. So in the notes, we have a generic equation for simple harmonic motion, which is given as x is equal to a, the amplitude, times the cosine of 2 pi f t. So we can find several of these values just by matching these two equations together. So in part A, the first thing you want to find is the amplitude, and just by looking at these equations, we can see that the amplitude is just whatever comes in front of the cosine. So the amplitude is 3, and it tells you in the problem that x is measured in centimeters, so this is an amplitude of 3 centimeters. Next thing is to find the frequency. So if you look at what's in the parentheses, in front of the f, in front of the t, we have an 8 pi in the top equation and a 2 pi f in the bottom equation. So we can equate those things and say 8 pi equals 2 pi f. We can cancel the pi's on both sides and then just divide both sides by 2 and see that the frequency is equal to 4. Remember, frequency is measured in hertz. The last two things just come from some simple equations. The angular frequency, remember that is the Greek letter omega, is just equal to 2 pi f. And since we just got the value for f, we can just take that and plug it into there. So that will give you 8 pi. And that should make sense because 2 pi f being omega, that means this item in front of the t up in that first equation is omega, which is 8 pi. And the angular frequency has a unit that is called, we haven't really talked about this much, but it's called the radian per second. And then finally the period, t, is just equal to the inverse of the period, so 1 over 4, or 0.25, and that's just the time, so it's measured in seconds. For part B, at time t equals 0, is the object located at equilibrium or at an endpoint. So let's just go back up to the original equation. The x is equal to 3 times the cosine of 8 pi t, and just plug in t equals 0. So when t is equal to 0, that means everything in the parentheses here, all that is going to be 0. Cosine of 0 is equal to 1, and 3 times 1 is just equal to 3. So at t equals 0, the position of the particle is at 3 centimeters, which is its amplitude. So that means it is going to be located at one of its endpoints. And you can just show these calculations for the justification of your answer. For part C, calculate the first time after t equals 0 that the particle passes through one of its endpoints. So this is a very simple question. You just have to understand what it's asking. Since we just showed that the particle started at one of its endpoints, the time it takes to go through one full cycle to the other endpoint and back to where it started is the period, which we already calculated earlier, is 0.25 seconds. So to get from one endpoint to the other endpoint, which is what this question is asking, the first time it goes through one of its endpoints after it starts, is just half the period. So just take the 0.25 and just divide it by 2, and you get the answer. And finally it says, calculate the first time after t equals 0 that the particle passes through its equilibrium position. Well, the equilibrium position is right in the center. So the way to think about this is, if the particle starts here and goes to the other endpoint and then back to where it started, we just said that to get to the other endpoint, that is half the period. Now we want to get to the equilibrium, which is the point in the center right here. So that's going to be half of what you just solved for. So in other words, a quarter of the period, because this is the first quarter of the period to get from here to here. This is the second quarter to get to here to here. The third quarter gets back to that equilibrium point, and the fourth quarter of the period gets back to where it started. So after just one quarter of the period, you'll get to that equilibrium position. So just take the 0.25 seconds, divide by 4, and you've got your answer.